A Telebyte video. Welcome to a demonstration of IEEE's 802.3 CG 10BASE-T1L compliance testing using 2.4 volts peak-to-peak and test mode 3. This demonstration will feature Analog Devices Evaluation Board and Ethernet PHY evaluation software with Telebyte's digital analyzer, probe, and software. Using the equipment and software shown in this demonstration, you will be able to identify problems, analyze transmitter power spectral density and power level. You'll be able to achieve repeatable testing, see clear pass-fail results, and generate printed reports with graphs. The equipment and software in this demonstration includes Analog Devices eval ADIN 1110 EBZ EVM evaluation board, Analog Devices Ethernet PHY evaluation software, Telebyte's 4975 digital analyzer and software, as well as Telebyte's 4975 P01 probe for signal capture. This setup can test with 1.0 volts peak-to-peak and 2.4 volts peak-to-peak. It can also test with test modes 1, 2, or 3. Let's take a look at the devices and software we'll be working with today. In the bottom left-hand corner, we have our Analog Devices Evaluation Board. This board receives its control and power via a USB connection that goes to the Telebyte 4975 digital analyzer, which is loaded with Telebyte's 500 software, as well as Analog Devices Ethernet PHY evaluation software. The evaluation board is also connected to the Telebyte 4975 P01 probe via an adapter cable from a 3-terminal SPE screw connector to an RJ45 connector. The probe also has a 100 ohm termination on the front, and from the back it is connected to the digital capture card that is installed in the digital analyzer. In order to enable USB power on the ADI evaluation board, do the following. At P5, connect a USB cable. At P4, jumper pins 3 and 4. Next, we need to connect the probe to the 4975 digitizer card. This is done by using an SMA to SMB cable, which is connected to the digitizer card and also to the back of the 4975 P01 probe. Then we need to set the attenuation to 0 dB. This is accomplished by manually sliding the red switch on the probe to 0 dB. Let's take a look at the software in action.
We will be testing the Analog Devices 10BASE-T1L integrated PHY Mac with a web server. The model eval, the evaluation board eval-ADIN 1110 EBZ. We're going to test in test mode 3 to test the power spectral density and the output transmit power level in a 2.4 volt mode. So what we'll do is we'll use Termite here. That's got a connection via the USB connection to the Analog Devices evaluation board. And I have some notes here in terms of writing to the registers to put it into a test mode 3. So we have a PHY write command here to enter software power down. We PHY write there. The message will say OK when it's completed successfully. And then we issue a PHY read to make sure that we're ready in the software power down mode. Then we write to disable auto negotiation. Then we enable a forced mode. And then we're going to write to register 0108 F as in Frank 8, the value 6000. This will put us into test mode 3, where we're sending idle frames. Then we'll power up the unit. We'll leave exit power, software power down. And now that's what all the commands we need to send to the analog devices, device under test. Now we'll run to the Telebyte 500 series analysis software, and we'll look at the spectrum analyzer mode. And here we see the frequency domain. So we have on our x-axis the frequency in hertz. This is 2.5 times 10 to the 7th, or 25 megahertz. And then we starting out at basically 10 kilohertz here. So we see the signal that's being output in test mode 3 from the analog devices ADIN 1110 eval board. We can take a quick look at this. We can put our 10BASE-T1L mask on, and I can choose the 2.4 volt operating mode, and we can click the lower mask in green, and then we can select the upper mask in red. So what we see here then is the signal is in blue, and the upper mask is the limit of the transmit power for the upper limit mask, and then the lower limit mask you can see is only defined out to 5 megahertz here, and it's the green line here. So the signal must stay within that, the mask limits, and it looks like it is just perfectly fine. And then the other step in test mode 3 is we're going to integrate underneath this curve to get the total transmit output power. So what we'll do is I'm going to generate a capture file of 2 seconds. So I'm going to sample at 500 million samples a second. I have the channel 1 on. The coupling is AC coupling and a 100 ohm load impedance with the digitizer range set to 2.5 volts in a 0 dB setting on our probe attenuator. So we'll take a 2-second capture, and this is the probe is connected to the analog devices evaluation board, and then we have a 100 ohm termination in the probe, and we're taking a capture of the signal to look at the output power with a 100 ohm characteristic impedance. Then we can take our analysis window here. I can select a window here, and we can analyze the signal just to make sure it looks like what we're expecting in test mode 3. And we'll look at the time domain view of that signal. Okay, so we have our signal up here. The first thing to notice is it does look like it's a 2.4 volt peak-to-peak operating mode, because I see voltages above +1 and -1 volts. And we can zoom in now to look at the signal. So what we're expecting is a 3-level pulse amplitude modulated signal, or a ternary signal. And what I see is I see +1 values here, then I see 0 values, then I see -1 values. So that does look like a valid PAM3 type of signal. And then you see the FFT on that signal. We're actually showing out to 250 megahertz. That's what our analyzer can go out to. And then we have our statistics here. So you see the ternary signal, the negative value, the 0 value, and the +1 value. So to look at the output power, I'm going to run a test report. So Telebyte has the test reports in the 500 software. We have the 802.3CG 10BASE-T1L reports, and then we also have the Ethernet Advanced Physical Layer test reports. So if I choose the 802.3CG standard, and we have the analog devices evaluation board, the eval-ADIN 1110 EBZ, and we're in operating mode 2.4. We'll go to test mode 3 here, and I will load the file that I just captured, and then we will generate a report. And then we're going to look at the PSD mask limits and also the output power level. So you can see the report comes up here, and we're generating a table of contents. Then we have our test information, so our software version, the Telebyte serial numbers of the devices, the date and time stamp on the test. And then we'll scroll down to the PSD mass testing here. You see transmitted power spectral density in the 2.4 volt mode. So again, we see the upper limit mask in the dashed red line, the lower limit mask in the solid red line, and the blue signal is our transmitted signal in test mode 3. And you can see that for checking the mask, we had no mask violations on the lower or upper limit mask. And then we integrate underneath the curve to get the total power output. So you see the minimum power is 7.4 dBm and the maximum power is 9.8 dBm. And we measured 8.6 dBm, which is a pass. So our test mode 3 signal is working just fine. Analog Devices did a good job on their transmitted power.
We would be happy to provide you with more information. Please go to telebyte-SPE.com to learn more, or you can send an email using sales@telebyte-SPE.com. Thank you for watching this demonstration today. Here are other videos that you'll find in this series.